So I'm looking at ChatGPT 04 Mini High, and at the time of doing this video, which is the when is it, the 31st of July 2025, I want to see the state of the art in it recognizing images of electronics, and it's still not getting it right, although I'd say it's much better than it was. So here's a circuit diagram I've used before about a year ago. It's got 2 op amps in it. I'll explain in a minute. And what did it say it is? It says the drawing is 2 op amps. That's fine. At least it got that right. Drawn side by side with a dashed line between them. Well, that doesn't mean anything actually. So the left-hand stage, it says, is an active first-order high-pass filter. And it goes into details about that. And it says the right-hand stage is a unity gain inverting buffer with bias current compensation. Well, let's look at the right-hand side one first. It is, in fact, an inverting amplifier. And yes, this is just standard to make sure there's no input output offset voltages when the input is grounded here on its own. So that this is correct. They got that bit right. What it's getting wrong is it's getting that op amp wrong, because it says it's a high pass filter, and I can see why it thinks it's a high pass filter, because this looks a little bit like to the untrained mind, so to speak, it looks little bit like some kind of Sallen key arrangement for a high pass filter, but it's not. It's actually all pass filter, which means it lets all the frequencies through. This just is an inversion, the second one. And it acts normally, this kind of circuit, as a phase shifter, because it's letting all frequencies through. So in other words, the frequency response is like unity, but the phase shift is not. It goes down negative, and you use it to phase shift sine waves or whatever, particular frequencies. You can't phase shift all the frequencies, just phase shift particular frequencies. For a particular amount, that is. So you design it to phase shift a frequency by a certain amount. So it said it's where was it? Yes, it said it's a first order high pass filter, which is wrong. Got the second one right, however. So that's not bad, but it's still got the main one wrong. So I've said the first op amp acts as an all-pass filter, however, and it thinks for 9 seconds. You're right, the left-hand op amp isn't a high pass in the usual gain frequency sense. It's a unity gain, first order all-pass. And then it gets that right, actually, which is rather nice. It's that bit is good. And it works out the transfer function, and that's spot on. It's like ST minus 1 over ST plus 1. That's a famous like a non-minimum phase transfer function. You can work that out. But anyway, the phase swings from minus 180 up to 0, and that's correct if I remember right. And then, of course, that gets inverted by the second op amp. It's a little bit tricky. It's something you might put on an exam paper for students to order to be able to work that bit out. One way you can do it is with the superposition principle, by splitting it here and grounding each input one by one, and taking each input in turn. So you can ground this point here, then take the input to there, and then ground that point, and then put the input in the capacitor and work the output out, and then sum them. That's one way to do a solution. There are other ways, of course. So anyway, it's still getting that wrong, but it's getting that bit right. The one thing it might do is it might be able to plot me the bode-plots. Let's see if it can do that. Plot the frequency response of the circuit. So it should be able to do something in Python, I think. Oh, there it goes. So it's writing a Python program. There's the transfer function going in. Oh my God. That's not very good, is it? It's got the phase right-ish. 0 to minus 180. but I don't know. Seems to have got the magnitude wrong. So I'll just say the magnitude should be, I think it's a numerical thing, but perhaps. It's fluctuating. Yeah, noise. I don't think MATLAB would do that, but I might be wrong. It's just because it's, I think it's supposed to be 0 and it's just seeing some kind of quantization effect, that's all. Let's see if I can fix that. Maybe a better way would be just to put it on a different scale, because it's put a ridiculous scale. Yeah, there we go. That's better. So 0 dB, and oh, that's a dB, and that's linear, it's unity. And these frequency up in radians per second, up to 100 radians per second, and the phase here. And I can't remember whether that's, I think that's right of the overall thing, because the second one inverts and goes back down again. So I think that's the right phase, but it's kind of right anyway. So that's not bad. So there you go. There's how it's seeing that circle, which is deceptive in a way. So it's not to be trusted really with electronics at the moment, although you can obviously get answers, and if you guide it a little bit, it's good. Whereas in other areas like mathematics, I find it's fantastic. There you go. Thank you.